did this. Oh well, I did a bad job of posting this to LinkedIn, but that's okay. Uh, I'm gonna record cloud. Oops, somebody preempted me there. Okay, here we go. It's what are we at here? November 20th. So the Vibecast. Um, well, it's I'm to say I'm busy might be an understatement of the year. This has been the fall. It's usually busy for consultants, but this fall has been absolutely insane. And I wish I could talk more about the projects that I'm doing, but apparently everybody has these ironclad NDAs, so I'm careful on what I need to say. All I gotta say is some of these projects are just insanely large in terms of the complexity that we're seeing companies and folks doing, and it's exciting to be in the space and watch, and as this technology becomes going from kind of experimentation to something more than that. And I'd say, one of my projects would directly touch close to 40 million people, and that's just, a random Thursday afternoon, right? So we're seeing massive uptake. Rob, how's it going?
Great. Great. And yeah, absolutely. You can hear it from every direction, that uptake and the level of conversations that are happening. Outside of the hardcore agentic engineering community, you can hear the quality and the curiosity just step up day by day. So incredible. Tons of stuff going on, Rube. I think just the one thing we may want to mention before we dive into to the coding session today is the global hackathon that's coming together, and sort of
Yeah.
put the word out to the community to be thinking about putting some teams together.
Yeah. So we've been discussing this idea of hackathons quite a bit lately, and and more to the point, like, what's the point of the Agentix Foundation? What are we good at? What do we want to do? How do we want to structure these? Because it's been in fairness to me, loosey goosey sort of approach that we've taken, and that's kind of purposeful, I guess. Just whatever. But what's interesting is we have a core crew that are really good at sort of improvisation of building things, vibing, but not just vibing garbage. We're getting really good at vibing high quality stuff that proves a point really quickly and shows the art of the possible, and how we can apply this in new and novel ways. So that what that really means is we're good at sort of hackathons, right? And some of the folks that have been doing hackathons, like our friends from Cornell and a few others that I've been mentoring, they're coming in first place. They're coming in second place in these top hackathons. So we've seen to be putting together a really good crew for doing that, right? And our friends at 42 are helping sponsor a hackathon in partnership with TV 5 in France. And this is and they're a pretty big deal. They get what, 500 million viewers or something like
That's
that.
right. That's right.
So
400 million
basically,
subscribers worldwide.
yeah. So they own essentially the francophone, world in essence, right? It's smaller than the English one, but it's decent, I guess. 500 million people isn't nothing. So they're looking at us and saying, why don't we do a sort of hackathon for good, right? Am I getting the story right?
Yeah, absolutely. The core challenge is that globally, on average, human beings spend 45 minutes a day searching for what to watch. So billions of hours of human hours a day trying to find something suitable for entertainment. And they have tabled with the Paris chapter and the Eugenics Foundation the challenge of providing a solution that can reduce that time. So
Yeah.
pretty interesting.
This is something Jed and I were just discussing. We have a little pre-show where I get everything set up, and Jed was mentioning, what are you going to do with 5,000 or 5 million agents running in a kind of parallel, concurrent fashion? Jed, what were your thoughts there?
Most of it was trying to figure out how all of that was running within the same environment while also talking to the APIs of the different LLM providers.
So the I
Under the
think what you're
hood.
saying, yeah, it's like, okay, I've got, like, what does the architecture actually look like, and how do you apply it? Let's say we want to deploy 5,000 or even 500 million agents that each represents a single subscriber within that pool of their supposed 500 million users. So how would we do that functionally, right? So what we're looking to do is take these self-learning loops, right, and hyper target those towards certain segments or personas, or in this case, actual potential viewers of that network, and then sort of optimize based on what we think they want to see in a sort of self-fulfilling learning loop, right? Reinforcement, a couple points up, negative, a couple points down, and then at a certain point you get this coherence. Now, what these agents can do now is allow us to spawn up literally 499 million different agents that exist just to study and pre-train based on a particular user and all the information we have available to that user. Now we can do that in parallel. So we spawn, I don't know if we're going to do a 500 million, depends on the infrastructure, but we hypothetically could essentially spawn 500 million. Now, in a 500 million scenario, we'd have a lot of information to parse. So you're creating these little agentic networks that are optimized just for each particular user, understanding that user, saving that to a user profile or database or somewhere, and being done. And that entire process can be done in like 20 minutes, 500 million times.
Right. There's so many different dimensions of this problem that agentic swarm orchestration can take a look at in order to break it down and then reconstitute it in a hypercurrent contemporary method with Agenics. So that's the hackathon, Ruth. It'll be under your technical guidance, we'll break the problem apart. We're inviting teams from chapters and individuals, members from around the world. If you want to participate, this is not an internal competitive hackathon. It's a collaboration. So everybody who is involved and is participating and brainstorming in different aspects will collectively participate in the results and or rewards or outcomes of the actual challenge and the potential solution that we put together collectively. So there is a landing page now. I think we got that registration form set up. Is that right, Ruth?
Yeah, we did get a page up on the site. Agentics, we did it yesterday. Let me share my screen quick here for you guys. Agentics.org/hackathon, I think it was. So yeah, right, here we go. Hackathon. And here, let me share it. It's basically, and we'll probably, oops, I spelled it wrong once, and now it remembers the wrong spelling. All right, I need the H. Here we go. Hackathon with an H. Maybe hackathon in French doesn't have an H. I'm gonna go with that.
Yeah. Hackathon.
Seems superfluous. All right, so I've registered, so I can't show you the registered form, but you've seen one registration form, you've seen them all, whatever. Put your name in, you're either an individual or a team. We're thinking all-star teams. Now, remember, this is a collective, so that means if you participate and you put in, something back, something that works, basically, that creates a pool relating to the overall sort of thing that wins. So maybe some other group actually wins and their system gets used. That forms a license that's being put into essentially a DAO. I think is, again, I don't want to play on the crypto part, right, but it's basically a way to bring people together so we all share in the profitability. If the algorithm or thing that we invent gets used broadly, then tvSync or whoever ends up using the algorithm will pay a license fee to use that algorithm that we devise as part of their core sort of optimization for their users or whatever it is that it ends up doing. So it's a collective. So yes, we'll have a winner of some sort, but the real value is in the fact that we're all kind of doing it together. And I think that's the part that seems right to me. I don't know.
Yeah, that's right. It's a collaborative effort meant to bring together agentic engineers and members from around the world to all lean in on a very big problem and all participate in the rewards and the outcome if there just happens to be a market value to the solution that emerges. And interesting to note that in this structure, we already have the next hackathon challenge tabled, which happens to also be from the Paris chapter, Tourism France is looking to address discoverability in the new era of GEO with LLMs and how to support their historic tourism industry across France. So we've already got the next one lined up and looking like there's a third coming after that. So this is a really exciting format. Collaborative, global, worldwide, right in our space, agentic swarm orchestration, problem discovery, everything. It's gonna be a lot of fun.
Yeah, for sure. So it's going to be different. And if this works, what I'd like to start us doing maybe is more hackathons, for good, for profit, whatever it is. And we will, focus on different problems. Let's try to do like at least one of these a month. I love building something. Now I got a reason to build something, right? So building for purpose.
Spectacular. Yeah.
Right.
And just to note, the actual event will be December 5th, 6th, and 7th, Friday, Saturday, Sunday. But there's going to be a lot of preamble leading up to it. And I just want to tip of the hat to Vincent Sider, Arsene Jean-Marie out of the Paris chapter for quarterbacking and bringing this all together. And Roof, your work with them to help have it make structural and technical sense, getting ready for it. Spectacular. I'm really excited to see what.
And we can't forget the crew also, our marketing crew. We got Matt actually did most of the work on this landing page, by the way.
Yeah, that's right.
So
yep.
Yeah, thanks Matt for putting that together.
And Leandro and team are working on the assets.
Yeah. So and Duri, who made this site look amazing. She's spectacular. So yeah, she's the one that did the redesign. She took all the crazy that I want because I like the sort of retro console aesthetic, and she worked with me. And as a former graphic designer, I think my wife tells me I'm like the worst person to work with because I'm very nitpicky on like fonts and locations. So thank you for that. She's done a great job there. Yeah, so that's what we're gonna do. So if you're interested, this is gonna be I guess the opens on the 3rd, and I'm gonna do a team. Not sure how. I'd like to see us like maybe get some team heads if you guys are interested in, like, we get Ocean, Jed, and Nick, and a few others that sort of lead teams. That'll probably work well for us. It's a fun problem.
Yep. Yeah, that's it. So just everybody who's interested, fill out that registration form, then we'll get that big list and we'll start to parse it.
Yeah. And let's see who else we got here. We got Nick. How's it going, Nick? I'm just looking through.
Good.
Yeah.
I'm just working away here, working on a LLM analytics system right now.
Okay.
So, yeah.
Yeah. You're still creating the Rust-based stuff, the sort of going from Rust to an NPM and a sort of distributed sort of package. Have you looked in the NAPI stuff recently at all?
I haven't got there yet. So when you tell me something, Reuven, it takes me a couple of weeks to sort of work it into reality. So it's in the back of my mind. It's on my list here, and I'll definitely be exploring that here in the next couple of weeks. All
right. Okay. Well, please feel free to share whatever you're building. You're always building some really interesting stuff. Love seeing that stuff. So today, what are we going to work? There's anybody have any review of Google's anti-gravity? I'm thinking I'm going to go through the installation process. I've been swamped, so I haven't had a chance to play with it. So I thought maybe I'll start there and see where that leads a little bit. I got a new laptop, which means I probably need to set some things up anyway.
I've been playing.
Yeah, what are your thoughts?
So, I mean, so far it says it's supposed to be better than I'm experiencing. I expected something a little better. I have an interesting challenge that I run through most of these where I say, just go on to my daily New York Times and print out my crossword puzzles. A super simple thing, but New York Times is massively scoped out to prevent any kind of bot. So it turns out to be a fairly challenging topic, and I'm literally working through it right now. And 2 minutes ago was the first time it actually printed out the puzzle correctly. But what was surprising is I had to walk it through a lot of the process. I had thought it would be savvy enough to figure that out, diagnose, get around, use Chrome, etc., and it didn't do that. So I just literally the first thing I've had a chance to do with it. I got a lot more intentions to do more with it. I had a problem. I couldn't seem to find out how to put my API key in, and it kept saying, you're maxed out on the 3.0 Prime or the 3.0
Okay.
Pro product. Anybody else see that?
Well, so far not so good for me. The install is seems to have crashed. Maybe I
Stuart,
get
you can't put your own keys into anti-gravity at this stage. That's explicitly stated on their page.
Oh, it says you cannot?
Yeah, they say it explicitly. At this stage,
Sorry,
it's
I
not
missed it.
possible.
Yep.
All right, so so far no good for me. It actually maybe because I've got Zoom going. Zoom's never friendly for doing installs, but the install I think has actually crashed on me, which isn't a good scene. So I'm going to have to kill that, I guess.
I mean, I used Google Anti-Gravity yesterday, and for me, the results were actually pretty good. So I pointed it to a website. In about 2 hours, it replicated the website. It remade it in Next and in JavaScript. Everything was working. Looked really good. Now there is a problem where you usually hit model overload or you either hit quota limits. Just say for the LLM to try it again, and then it just continues where it left off. I also had to make me a prototype of a game written in Rust, and it actually worked pretty fine. So the only thing is that it can have errors or model overload because a lot of people are using it. But if you tell it just to try again, then usually it gets around those errors.
All right.
Thank you.
I don't think I'm going to be able to install it while using Zoom, unfortunately. But or maybe it's just locked up. I don't know. But it doesn't I don't think it likes Zoom in installing because it basically doesn't do it. But what I want to do, there's no shortage of stuff. So I want to do, and I'm going to show you some of my experiments and some of the things I'm working on. I was unfortunate this week that I was doing some large scale testings of swarms, and I maxed out my Claude code or whatever within the first 24 hours. But I've got more than one account. But that was a little unfortunate, so I got to be a little more careful on that. But essentially, I'm going to show you some things, and like everything. And by the way, I just muted everybody. If you want to talk, just unmute yourself. This one doesn't auto mute for some reason. All right, so here we go. I'm going to I'm going to share my screen here. Just one sec. Actually, I'm going to switch it up. I've got this laptop that's got multiple screens. It's actually great for this because it makes it puts it in a nice spot. All right, so what I'm going to show you, I want to show you also my NeuroTrader stuff. I've been looking at ways to make that work as essentially within like a Claude Code Web or even the anti-gravity, where you could basically just point it at my particular. What I really wanted to show you was basically using it in anti-gravity, but unfortunately I wasn't able to get anti-gravity installed. But so that part of my story, well, I'm going to have to improvise here a little bit. But what I want to describe is sort of the idea. So I'm going to make NeuroTrader open source. It's, selling it as a direct sale would be a whole business, and I don't think I want to make my business the business of NeuroTrader. I like doing the NeuroTrader work, but I think that making it open source, allows me to mix and match it and allows others to run with it. And it's a really cool, powerful system. So the concept of NeuroTrader is actually, it's made up of a whole bunch of different packages. So there's this modular structure to it. So all the parts of the system are a kind of collection of NPM that you can include, right? So you include these at NeuroTrader. So there's core and there's the protocol, and there's a whole variety of these different components you can add and mix and match to create a kind of modular Lego style sort of approach. So you've got NeuroPath packages you can add that add the ability to do different types of prediction. You can then apply that in a whole variety of different patterns and ways. You got risk and all kinds of things. This thing even has an accounting system that's been built in here, sports betting. You've got, so you can pick parts that you want. And what's also interesting about this platform is even though it's focused on this idea of trading, trading in essence is like the form of most business to some degree, right? Just because you're trading in stock in a future date, that's more mathematical, but you can apply this as part of like the way that you handle the finances of your business because the system essentially has an accounting system built right into it. So let me find the accounting system here.
Quick thing, Reuven. You're sharing your anti-gravity installer and your task manager screen.
Oh, here. Sorry, guys. One
No
second.
problem.
Let me try it. Let me share again. Today's not going so good for me. Thanks for the heads up. And how's it going, David?
Yeah, it's going pretty good. I've been out of the fold a little bit because I joined the Agentforce AI team at Salesforce here in San Francisco. So I've been a little bit swamped with some really crazy high volume enterprise AI stuff going on. But I try to make, I'm trying to figure out how to get back into spending more time with the Agentic Foundation because it's so close to my heart. But, and I'm looking for opportunities on how I can, get maybe, Agentforce, Salesforce, AI stuff connected with what we're doing at the Agentics Foundation. Always looking for opportunities. So trying as much as I can to fly the flag.
We should do a hackathon.
I know. I was thinking about that, man. I'm thinking about having a Salesforce team and Agentforce team.
Yeah, guys, I'm agnostic towards the platforms. I really don't care what we use. I think that what we need to do is let's do an agent off, or better yet, let's do a mind meld where we merge the stuff that you're seeing me do with the stuff that you're doing and see what kind of crazy love child appears from it.
Well, I'm gonna throw something out here. I got to be careful what I say, but Salesforce has like almost 1 billion users of its product, super successful enterprise business product, but they're very conservative in how we're architecting and building and deploying AI, agentic tools. And when I compare what we're doing here in the Agentics Foundation to what a large business enterprise is doing with AI, we're like, really, honestly, guys, I keep saying this, the Agentics Foundation is at the cutting edge of the industry compared to what a humongous successful SaaS company is doing in the business space. We're light years ahead of them, like really light years ahead. You should be proud of what we're doing here.
Yeah, it's sometimes it's hard to tell, right? I'm wrapped up in my own self-fulfilling manifestation of the things I build, right? What does the world look like in 10 years? Build that, and then suddenly that's the thing that I'm known for building or whatever. It's hard to step out of your own bubble.
Well, yeah, and that's why I joined Salesforce. Like right now, I'm actually architecting, agentic conversation and memory for Salesforce, for Agentforce. So, which we were doing a long time ago, and now you've got AgentDB and the memory bank and all that, like a long time ago. So that's how ahead of the curve we are here.
Nice. Well, really, really appreciate your support, and we should totally do that hackathon of some sort. Let's just build things and see what we can do. Our biggest constraint, just generally speaking, is lack of like infrastructure to support these. When I'm doing a 5,000 agent swarm and maxing out my account in the first 24 hours, that's essentially coming out of my pocket, right? So I think our biggest limitation is the ability to support the underlying things that we're doing. If we had more like technical resources or like, I don't know, some like just the ability to test our stuff more broadly, we'd be able to push the boundaries even further. So we're limited by being poor. Like everything you see me build is essentially for the GPU poor. I don't know if that makes any sense whatsoever. But so with that in mind, hopefully I share the right screen this time. So this made up of modules. It's made up of a variety of things you can plug and play. So much like an ecosystem you'd see in a larger company, SaaS driven, you've got different parts and different products that you can plug together in different ways. I built it in that sort of fashion. So for example, the agentic accounting system, which would literally work for any sort of corporate treasury that involves looking at, compliance, looking at, in this case, it's optimized for like investment related activities, but it's trivial to sort of modify to look at the requirements of your particular business in terms of the actual assets and accounting itself. So to include that, all you're doing is basically using this. So this would be like an MPX command or NPM if you're depending on how you're using it. And you basically say, build me an accounting system, make it the world's smartest accounting system, and go. And I built all these things using a high performance internal Rust compilation. Now you hear me talking about Rust all the time. What's interesting about Rust is its speed, its performance, and the ability for AI to build things in Rust that somehow magically work the first try. And where Python and TypeScript take you down these weird rabbit holes and lie to you and say, yes, I built it, it's the world's best. It never is. But with Rust, it is. And it works, it takes several hours of sort of combinations and testing and optimizing, but generally speaking, what gets put out from Rust works no matter the complexity. So if you're looking to build something crazy, now the problem with that is you now have this limitation of having to compile the thing, which is a pain in the ass. So what the NAPI-RS algorithm, well, it's not an algorithm, it's like an integration for Rust, allows you to do native compilations for that particular environment. So think Mac, Linux, Windows, various flavors of Unix, that sort of thing. And then it basically allows you to deliver that directly as an NPM, which are super easy to install pretty much everywhere. And then rather than using the V8 library, which is essentially the core kernel of like Chrome to operate the node system, it actually switches that with the Rust system, which is many, many times faster and more capable in terms of loops and optimizations. So when you're looking at these systems, what you're actually seeing are the Rust crates that make up this system. So if you go, let's go to my crates for a second, I'll show you that. So it's two parts. So we're gonna go to my most recent downloads. We'll go to recent updates. And you see here, I've got my Gentex robotics. That's a whole other thing I'm gonna have to show you guys. The robotics, that's part 2 of what we're doing today. But before we get to robotics, we've got these NT bindings. So NT stands for NeuroTrader, neural networks. So these are the libraries that make up the core NeuroTrader system. So you can run these directly in terms of the highest performance you can possibly get. We're talking nanosecond sort of loops and capabilities. You run that directly using Rust. Now, there's a bit of overhead when you're bringing it into the NPM, but we're talking minor, like less than 1% for most of these things. So it's so low, it doesn't even matter. The benefit to this is you can sort of use this as a kind of derivative. You can say, take one of my libraries and repurpose it for something else. So you've got, all these different libraries. So the core here, let's go to the core, this is the sort of core library itself that kind of connects everything together. Now, where you really want to go isn't here. You're going to want to go to NPM. Let's go to NeuroTrader. So this is all those components packaged together. And I haven't even announced this yet. So thanks for everyone who's downloaded it. That's not bad for something I haven't put out publicly, really, other than this. All right, so continuing. So these are the key capabilities. So this is what you're getting. Now, okay, so I'm showing you all these crazy features. It's self-learning, it's got tools, it's crazy fast. But the key part, and this is what you need to understand, is all you need to do to start trading with this system is you're going to grab, where I got to find the part here, is basically this. So we're going to go to Claude Code. All right. And hopefully I don't show any keys because I love to expose my keys. All right, so we're gonna go here and we're going to we're gonna tell it we're gonna go to my generic one. I don't want to get it commingled with the code, so I'm gonna go and use my Vibecast. And you guys can see this if you go to the Vibecast, you'll see a branch appear based on what I'm about to do. You can use it and play with it, whatever. All right, so what I'm going to do right now is I'm going to basically tell it to install MPX so remember, there's two ways to work with this library. One is an NPM, and this essentially allows you to sort of assemble the parts with code. The other is from the CLI, and that in the CLI or MCP allow you to interact with the system like a service, right? Like a secondary third-party application, and so it's more, app orientated versus code orientated. The app orientations generally works faster and easier. So in this case, if I want to go with that, I might go with MPX install, and then I don't need the install, so I'm gonna lose that, and that's it. That's gonna give you the CI, and then I'm gonna also tell it to review the README and use the one sec, guys. I'm gonna give it the API key. I'm not gonna give you the actual API key because I have it in this NeuroTrader ENV here, but I'm gonna, and this is the part actually that's the most, I don't know what tricky is. Maybe that's the wrong word. The part it struggles with in Claude Code Web is finding the env. Even though it's in the secret, it always thinks to look for like a .env file that doesn't exist. And I'll say something like use the API key from the system secrets.
What is this API key that you are providing?
Sorry, say it again.
So Alpaca API, what does it do, this particular API key?
Oh,
Is
okay.
it...
So I'm gonna get this I'm gonna get this going here in a sec, but I'll show you that. Okay. So this is this is a trading system, right? So the trading system, essentially, it needs real-time data to know and understand what's happening in the market. There's lots of them out there, but this one's free. And the drawback to the free is it doesn't do historical unless you pay for it. But what it does do is gives you, assuming the market's open, which would be crypto most of the time, or stocks right now, and then you can get it to study the structure of those stocks. Now I can spawn dozens of different agents using Claude Code Web in my system, the NeuroTrading system here that I'm showing you, to do lots of different types of analysis and potential trades. So this system also operates in a paper trading capacity, which is what is the API I just gave it. So that essentially allows it to simulate the trades using real market information that's streaming from the market provider. It's not particularly fast, but it's good enough for sort of training the system. And then you can get a feel for what it is and how it's going to operate over an extended period of time. So you might let it run on paper trades for a week or longer while it kind of figures out the optimal strategies for how to do certain types of investment based on your risk level or how much money you have or how much money you're willing to lose sometimes. And if it's figuring that out all the time. So we can correlate that with things like a poly market. So the poly market would be like a prediction of what's going to happen in the future. And this poly market system is actually surprisingly accurate at predicting a lot of things that you wouldn't think are possibly predicted based purely on sentiment. Like people are like willing to put real money against it, which makes you think more analytically about the problem. And then that very thing makes the prediction more likely to happen. You can correlate that back to the psycho, structures that make people sort of want or do these sorts of things, and analyze that, and then apply it to your trading patterns. So it creates a kind of not only a market signal, but it creates a kind of human psychology that can be analyzed as part of the process, which is crazy. So then you get all these other various things.
Just a quick thing, Ruben, from Mondvi. Alpaca, sorry, I got some background noises. Alpaca is a trading platform that has market data feeds, and it's built very modern. It's built with lots of APIs, so you can write code to do programmatic trading. And there's lots of them, Polygon and lots of others. So and some of them are free, some of them you pay for, some of them you get different levels of API control and stuff. Alpaca's been around for a while. I've been an Alpaca user for 5+ years. It's really good.
If you're you start with Alpaca, it's cheap, easy, and free. Yeah, sorry, go ahead.
Oh no, I was just two questions. So first of all, I was wondering, why did you use Alpaca and not another free API such as Yahoo Finance? Yahoo Finance,
I use all of them.
Yeah.
I have all of them.
What you end up doing is you find that that these trading platforms, they try to lock you in. They want you to pay, right? So they only give you a certain amount of free access. They either API, rate limit, amount of data, type of trades. And so you generally, like I have built a trading system and I have like 29 different platforms that I use in order to get the data feeds and the market feeds and the API access. So, there's lots of them, and you have to figure out which ones are giving you what you want basically for free, or if you want to pay, you pay. There's just so many of them. Alpaca is pretty rich in what it can do.
What's great about Alpaca is specifically its paper trading capability. So what you and you can fake paper trading without the paper trading system, but what this gives you is the ability to understand the real information from the market without and executing, different types of purchase strategies in a way that responds and then realistic sort of response. And then once you're comfortable with that, it's a really easy transition to like their real trading system, right? So some of them, not all of them, will have paper trading options. Now, ultimately, what you're really trying to do is get faster than those systems, but it really depends on your trading strategy.
Sorry, Ruth, I have a question.
Yeah, sure.
In case that you have access to historical data, so we don't have to wait for 1, 2, or 3 weeks, and actually we run for the last 10 years. Is it ready, the system, to do that? There's something that it will run the simulations or backtest the simulations so we can train the system faster? It's already available?
Well, Alpaca, I don't think Alpaca doesn't really provide a backtesting historical trading analyzer.
That's easy to do, though. I do. So
yes,
I built.
There's lots of platforms that you can leverage to do that.
That's literally what I built. So essentially, if you go into my system, you've got all these different sort of packages. So here, these are the crates, and these explore different things you've got available. So in this case, this would be the multi-market system. So a multi-market system allows you to create your own back testing, right? So you don't need to sign up for any of these services. The only service you really need is the service that allows you to trade, right? So that would be like Interactive Brokers in the US or Alpha Vantage or whatever, wherever you happen to reside. There's usually different sort of API centric brokers that are the main provider in that region. You find the one that you want. What this does everything that sits around the trade. So if you want to do back testing for the last 10 years, but if you have the data, that's where this works best. So if you don't have the data, the system will attempt to go find that data through either paid or free sources. You can start with free, and it'll go and basically use the web search capabilities built into Claude Code or whatever. It's okay. You're getting the same crap everybody else is getting. The ones that are actually truly successful in using this system, they've got their own source of proprietary data that they've collected over an extended period of time that they can then correlate to these different market segments, right? And so here's the market data aggregator, for example. So the market data aggregator creates and unifies interfaces that fetches data among multiple providers, including Alpaca, Polygon, Yahoo, Alpha Vantage, and Crypto Exchange. I support every single one that's ever been created. It can create new ones, and if it doesn't exist, you just point the system at it and you say, go build me that particular interface, and it uses this library to basically create a new provider that wasn't there before. And depending on the provider, you got real time and historical. So you can see that, right now I support pretty much everything you want, at least in that department. And here's the SDK, whatnot. So then you've got these different forms of predictors. So you've got something called I can't even pronounce it, conformal prediction. So the system also encapsulates this idea of creating and predicting based on different types of structures, both long, multi-day, multi-month, years potentially, but also really, really small segments. So it turns out the system is best suited for making truly accurate predictions, but they have to be under 100 milliseconds. The most accurate prediction it can make is actually under 10 milliseconds. That's interesting because the time it takes you to get from the information from New York to London takes about 16 milliseconds. So it's pretty freaking fast. Now, what this thing does is capable of making very, very narrow mathematical, generally, types of reasoning predictions using causal loops. What has happened, what is happening, and what will happen. But that all happens in sub-millisecond, microseconds generally. And when you apply it to certain problems, you have a narrow window where the thing is actually moving faster because of this idea of prediction than the speed of light between New York and London. So at that point, you have the ability to essentially, I don't know what the right word is, but front load the intelligence. So it's able to understand slightly faster than the others for certain problems. And these problems are generally mathematical in nature, but some form of sort of linear equation of some sort, most likely. And that's what a lot of this is doing. So it's able to do that in two millisecond latency, and then it vectorizes that to create a learning sort of hyper multidimensional learning structure that basically moves in both temporal, I said loops, what's happening, what's happened, and what will happen in a really short succession, and then creating multiple connected versions of that in the vector. That is happening all the time, and the system is learning essentially what works and what doesn't, and then applying it as quickly as it can. In between the two, there are these agents that spawn up. So the agents, and you can see what else we got here. There's so much stuff in here. We can just do tell me about.
Is that stacked against the communication to receive the data and then respond, or is that meant to happen on a superluminous basis?
It's meant to understand, reason, respond. It's an OODA loop. Was
So
what it is.
Still stuck with the speed of light issue when you're communicating or sending a signal from wherever the decisions lead to the exchange.
Yeah. So basically what I'm stuck with is the limitations of everybody else around me. So the problem is, one, most of the providers, all the providers, don't work in sub-millisecond increments. They're limited to about 100, maybe 50 milliseconds to 100 milliseconds. And I'm working between 50 to 1,000 times faster than that. So nobody is able to get my information, and I'm not able to execute on it because there's a fundamental traffic jam in the trading universe that I can't overcome. So to overcome that problem, what I'm doing is using that time to make more informed decisions, and knowing that I'm not able to overcome the limitations of speed. So I can't front load it really at that point. But what I can do is over analyze it or be smarter than everybody else in making the request. And the system is figuring all that out by itself. All right, so basically, to run this thing, all you need to do is do exactly what I just typed. So you're gonna go into whatever you can do this if you're in this case, you're not gonna use this. You're gonna do this. You're gonna say, tell me about the MPX neural trader. That's it. That's all you need to type. And that will set open a sort of Pandora's box where it can follow the sort of yellow brick road here wherever it leads. So the system essentially, when you run that, so let's just run that quick and I'll show you what that looks like. NPX neural trader. That's essentially going to kick off a series of installs. And it's not the lightest app in the world for all the things I've just shown you. You gotta download several distributions, and it's an enterprise application. So the architecture is how you build for large scale systems, right? This would be used in a bank or something. All right, so now we've run that. It's installed it. You get this terminal, right? So you got the high performance neural trading system with GPU acceleration. And yes, I included GPU acceleration because why not? If for a lot of the problems you're going to want to solve here will need GPU acceleration. That as I point out frequently, I'm GPU poor, so I'm using just my local GPU for most of it, but the reality is this GPU stuff is absolutely crazy. So for some of the problems you're gonna solve, you can literally you can create these loops using the same concepts that I'm using for those sublinear loops that I was describing, but you can do it a trillion times or something beyond that, some giant number. And so depending what you're doing, you probably want to explore that. And to Jed's favorite place, um, Rackspace or one of those sort of environments would be perfect for this because this entire environment is ephemeral. There's a federation option built in here that allows all those processes, whether local or on Rackspace or whatever, to run in a federated fashion, which allows them to sort of communicate with each other sort of in a distributed network. Now, I'm using that quick QUIC protocol, which basically allows each of those to communicate with each other with no handshake. So it's instantaneous sort of communication between, you're limited by the network and the speed of light. So, but I've been deploying this on Fly, which has global, and it's great. Works perfectly. It's cheap. It doesn't cost much. So you're basically just letting it follow this kind of path here a little bit. Now, for the other things I was showing you, you're going to want to do similar things. So we go back to this for a sec, and if you scroll down on my npm page here, I'm going to just
Ruve, on NeuroTrader, are you auto switching to a different API when you hit rate limits? And if so, how?
Yes. Really, if you're free, you're gonna need to sign up, and you can literally get the agent to sign up for read the terms of use. Don't be jerks about it. If you're making money, pay for the service. But while you're learning, you do what you need to do to learn. But you can sign up and use multiple accounts. Now you're gonna put that in an env file, and you're gonna tell it basically to create a kind of rate limiting or round robin or some sort of multi API use. You're just going to tell it to do that, and it'll figure it out. It's got all the things it needs to do anything it needs you to do. The intention is you just ask it. This is like it's powerful, but it's made for vibe coders, right? It's made for you to don't ask me how it works. Don't ask me how I built it. It was hard, but it works. That's the essentially who I made it for. That said, don't be stupid. This system can be used for all kinds of interesting, use cases which are perfectly legal, and you can also be used for stupid things like and betting and things that will probably put you in a place that you don't want to be. And if you're using it for someone other than yourself, that is a securities vulnerability to you. So what you're not going to do is go start a personal financial business without getting the right legal and regulatory other things in place, because you'll end up being, when stuff goes sideways, you'll be left holding the bag. So don't do that. Anywho, okay, you scroll down the page, you've got features, you got market data, you got brokers. Each of these can be used. All right, so now if I want to use the npm, this one, I'm going to go back to my right here, and I'm going to go back to Claude for a sec. And so it's doing whatever it's doing. It's coming up with ideas. It's telling me everything it needs to do. Now I'm going to say, can you also explore I got to put the npx. I'm going to do this as an npm. I don't know. We'll do npm. Again, npm is an SDK. The npm allows you to build with it so much as operate it. You're operating it still, but you're operating it through new code that you build to operate it. So it's different. So if you're vibing, you can try both different approaches. It's kind of interesting to see where that takes you a little bit. All right, so now it's exploring that. Oh, and you know what? That anti-gravity thing actually is installing. It just takes forever to install. So maybe we'll get to anti-gravity here in a moment. All right, while this does this thing, I want to show you some other stuff. So what do we got here? All right, we're gonna go to, where the heck did I put that? I gotta go to my Git. I built too much stuff, and I can't remember all the things I build. But I built something cool, but I'm not sure, but I think it's cool, and I want to show you guys because it's cool. All right, so we're gonna go to my repos here. I gotta remember what the heck I called it. It's Ruv Vector. Yes, I named another thing after myself because I've got like weird some kind of neuroses, I guess. Ruv Vector. So I've been thinking a lot about vectors. Yeah, I've been on a vector kick, as you guys probably know. And there are some really great vector databases out there, you know, and I'm doing this not because it necessarily needs to be done, more that I just wanted to know how to build a original high performance vector database from the ground up with no lineage to anything that currently exists, really. So that's what I was trying to do. And of course, because it kind of works with Ruv, I put vector after it, and I got Ruv Vector. All right, so basically what I was trying to do is using a few different approaches here, you know, to create the fastest possible enterprise scale vector system you could possibly build. That's what I'm trying to do. And so sub-millisecond queries using HN small world, whatever they call that. That's the sort of hyper optimized indexing. I also want to use SIMD for optimizing against your CPU and GPU. I want to make it easy. I want to be able to deploy this to different environments, probably embedded into NeuroTrader, into Claude Flow, into Agentic Flow, and other systems that I built that all need something more than a single SQLite database running locally. And I want this to be fast, like not like Supabase is really slow. I want something that's as fast as it could possibly be for all the things I just showed you earlier. So and this is what I built. This, you guys can try this. It's a little rough around the edges, but you can probably vibe it in shape. Latency of 0.05 so half a millisecond. I've got throughput of 50,000 queries per second. And this is just running on low, crappy code spaces, very low memory, and really high recall. And so I can quantify, I can quantify it and do all kinds of things to it. And I did the same approach. So I built this using a series of includes like I built with the NeuroTrader. So similarly, you can mix and match these pieces to create new sort of novel, you know, integrations of it. I also built this to operate in the actual browser itself. So the browser, so you can operate this completely high performance vector built in Rust that are compiled to a WebAssembly WASM that can then sit in a browser and use the IndexedDB capabilities of the HTML5 specification, which allows you to save local information to the sort of person viewing the page, and use that as a high-speed vector that learns directly from your browser. And that's 800K. It's smaller than an image. So yeah, built all that. So let's explore this a little bit. That's what we got here. Let's go to the crates. That's always the most exciting place to look. So we've got different crates. We got profiling. We got the integration. Oops. Oh, Google's trying to do this. Better not require a restart. If Google makes me restart my computer, I'm going to freak out. All right. No, it looks like I'm in anti-gravity as well. All right. So here we go. Getting a bit of a delay here. Google decided to do something. Let's look at the README here. So this is, I'm going to clean this up a little bit, but this is essentially the WASM that allows you to integrate the possibly the most performant vector DB in the market directly in your browser. And so you can you can run this npm install. And yeah, you've got, have I published it npm yet? I might not have published this to npm yet. That is something I need to check quickly. Let's do that. npm. I'll do that here this afternoon then if I haven't. Ruv Vector. No, I don't think I've published that. All right, I'll publish it. But for now, you can just go and get the repo, which is the Ruv Vector repo, and just point at that, and that'll get you up and going pretty quick. I'm gonna pop that into the text area as well. It's basically one last thought. It's basically AgentDB vector, but hyper optimized for enterprise use. Yeah.
I'm just curious. So if we had a a directory of say 50 files, mixed files, PDFs, Word, Excel, PowerPoint, etc., could we point this at that and say, pull it all in, absorb? So does it have the ability to read the different file types, etc., and digest and throw it in the vector DB?
Well, you'd vibe the document ingestion. So you're gonna get a document parser. Now, I didn't bother with that because they're trivial to build, but basically what that's gonna do is it's gonna parse whatever source of data you want it to vectorize. So in that scenario, like what I might point it at, I had a project this week for just as an example. It's in the legal space, and they had a repository of documents, around 3,000 documents. So it's a mid-size, it's smaller sized legal tech startup, and they had access to all their case done. And I basically pointed my swarm at it and said, learn everything there is to know about this business, how it operates, how how successful it is, what the psychological characteristics of opposing counsel looks like, and then use this vector structure to give me all the things that I don't know. Find novel new connections between all that information. And I let it go. And then an hour or so later, it's looked at many, thousands and probably hundreds or millions of different variations, and it's discovered all these different ways to optimize their business. How when it gives suggestions when they meet a certain lawyer that they've interacted with before, all that's transcribed, right, as part of the court proceedings. So the system is able to then realize, okay, based on that, you should probably negotiate in this a particular standpoint. And actually, if you provide an offer before you ever get to trial, you'll increase your profitability and the amount of time it takes you to get to a final conclusion by X%. That's what these systems are doing. They're learning about the nuance of your business. They're applying it in new and novel ways and giving you a kind of guide to how to operate with it. That's what these databases are doing. So they're learning, right? So in this case, let's go to the profile. The profiler, this is optimizing it. We've got, all the various parts, but essentially this entire thing can work in your browser. So if I'm going to go and I could literally just tell it to create, rather than having to go to Supabase to do the structure, I can literally have it load in my browser, and then periodically I might do a sync with a Supabase, as it learns. But the more the user uses my web app or my mobile app or whatever it is, it's learning on their particular habits and then periodically sending it back to me. Now, I don't necessarily even have to send it back. Now, if I want the system to be purely secure, I can actually have the system not, to sort of run a kind of autonomously from me itself. So a lot of these services are using LLM call-ins, right? You have your chat bots and you have your other things. So I can create a loop that exists where it doesn't actually communicate to me as the provider of the service, but it communicates sort of separately from me in a combination of the front end and I don't know what you want to call it, the sort of LLM requests, the chats, and the AI integration you see on all these sites. And that's what this library is intending to do. Do I have a README? There we go. So essentially, this you include the Roux vector. I haven't published it yet. I will this afternoon, but maybe I have. Let me just check. Maybe I just didn't publish the root. Let me check that just for you guys.
You did. You did
Okay. Yeah, I think I just need to double check this stuff. I don't think it's fully published, but some of it's published. The crates are definitely published. And essentially all this crazy stuff I'm telling you is facilitated by having a system capable of learning and applying those learnings in a hypergraph structure. I'm gonna pause for a moment. There's a lot of freaking information I just dropped there. Am I delusional today or just blabbing? Let's see here.
I have one clarification to make here, or a question. I remember you have done there was a package called FACT that was supposed to replace RAG vectoring. Sorry. And then there is a agent DV. And now we have this one. So what is the evolution here, or what is replacing what, or?
None of my things replace anything. They're augments to a core, right? So I'm using Fact actually, and you're probably using it without even knowing it if you're using any of my tools. So the what this does is allows me to understand the prompt caching within the request to an LLM. And essentially what happens when you make similar requests to an LLM, rather than it charging you for the making the same request twice, it essentially allows you to make the same request again. And that creates a significant improvement in terms of time and cost of making requests to LLMs. Now, the problem with that is they don't exist for more than usually a few minutes, but with the right techniques of sort of poking it every now and again, you can actually keep it alive. Now, by keeping these caches alive, you can greatly reduce the cost because most of the things people are asking for are generally the same. So let's hypothetically say you've got a welcome message on your homepage and you've got 10 different variants of that, and you want some bit of change, so you get the LLM to generate that text on your homepage. Now, if you don't invoke the cache, you're paying for that every time someone visits your homepage, and it gets really expensive. If you do it using this Fact approach, it'll just keep it alive, and every subsequent request is free, and it happens in almost instantaneously. Now, using that, you can create structures that are applied to the prompt cache, similar to what I'm showing you in a vector, that exist in this area between the LLM and the requests that are being made to it, that kind of creates a kind of caching of all that information that you can then request more quickly and more effectively. So you're essentially running a kind of pre-request, having all that information available to you and using that and keeping that alive. And then that provides the ability to structure it in ways that are already known to the system. For example, if you have two different possibilities, one that's correct and one that's not, and you have a way to measure what is correct, you can then have the cache in place that basically always gives you the correct answer to that problem that's commonly asked. And that sidesteps the need to do any kind of fine tuning. It auto fine tunes for you. Taking that a step further, and this is something I published the other day called dspy.ts. This is based on dspy Python, but I re-implemented it using AgentDB, which does the self-learning and the structures of Fact and all the other things I've been showing you today to combine all these into a system that learns how to learn. So in this case, it's faster because I've rebuilt the entire dspy platform in Rust, which you can get on my crates. So it's like orders of magnitude faster than Python, which is slow and cumbersome. Then I package that up again as a WASM, which means you can run it in your browser or as a crate or in the MPAI blah, 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 which allows you to run it in Node really easily. So lots of different ways to consume it. So in this case, you've got all these modules for prediction, chain of thought, but this takes that previous concept I was describing and essentially allows it to run, allows it to sort of self-run. It allows it to learn by itself, and it's optimizing the prompt. And for that, all you need to do is install it this way: npm install dspy.ts and just say, do something crazy, learn. That's it. And it'll learn. And I've included ONNX, so you can use local models. So it can learn and optimize crappy local CPU-bound models, and it won't cost you a cent. So you could literally deploy infinite amount of these agents with no external model other than some ONNX LLM that doesn't really cost anything, and have it learn over time and just do its thing. And your only cost would be to your sandbox, which are next to nothing. Like I did a 5,000 agent run the other day, and that cost me $12. So it's
But how is that learning actually then, I guess, transposed into something meaningful? Because we see the agents are running on your lab, on the local infrastructure and learning it. But is the learning captured somewhere that can be leveraged for other projects as well? Like how does that transition work?
Yeah. So there's a federation component. So the federation, I built that into where we got where are we at here? I gotta find my right screen. Sorry guys, one sec. So in in the agentic flow system, and I don't know what happened to the screen here, but in the I get one sec, guys. I'm gonna fix this. In agentic flow, there's a federation system. So the federation system, I'm basically just using Supabase for this right now. I might do a hosted version of that crazy Roux vector thing once I do a little more digging on that. But what that basically does is allows all the different agents to essentially collectively work with each other with a shared sort of persistent state of learning and database using Supabase. I think I'm using the PG vector, but you could literally just use straight up regular Supabase. All right, so this is telling me more about the trading system. Just explore it. You know, back to the trading, ask it questions, and just again, don't be dumb. I don't want you guys to get in any trouble. So don't, you know, if you don't know what you're doing, you probably shouldn't be starting a finance company. So don't do that if you don't have to. All right, now we're gonna go here. We're gonna go and we're gonna do DSP, dangerously skip permissions. And what we're gonna do now is we're gonna ask it, you know, tell me about the MPX agentic flow federation capabilities. I love the word federation. Every time I see it, I think I'm like, you know, part of Star Trek or something. But yeah, so that's what you're doing. And you can do that just as easily. You know, I like this interface, but we can go back to here and we can do it in Claude Web just as easily. So here we go. So this is running. Yeah, it's still struggling with the API. I don't know what's going on with Claude Code Web, but you're probably gonna have some problems with the keys. I don't know. It doesn't seem to pick up keys well. I've got the keys in there. Sometimes it does, and it works really really well, but other times it just doesn't. So you know, anyway, so
Check
go in
the
here,
keys
go
are
to
being
Vivecast.
overwritten.
What was
Sometimes the
that?
keys are being overwritten, so you need to add a suffix to the key and then tell it to reference the suffixed key instead.
Oh, that's a good idea. Suffix key.
Or
So
do you have
suffix key would be like doing something like this. Echo
I actually
echo
told
the.
the name of the file to look into. So it was the same problem I had, but then I said, look in that environment file, Claude Code
I'm not
Web.
using environmental. I won't use environmental variable files for this. Like I wouldn't, if I were you guys, I wouldn't either. I don't know where this is being stored, where this is being run, but you know, the likelihood of this being exploited, let's be honest, is high.
But even
I
for in your secrets that the drop down that you have on the right hand side, neuraltrader.env, you can
yeah, I'm not saying that isn't. I'm saying that's insecure too. I'm just saying like one
Oh.
thing I can do potentially to make it slightly less insecure would be not to use a .env file. But I hear
In
you.
the code says it's alpaca key and not API key. Maybe that's
Yeah, I didn't look that closely, but in this, so I'm not going to do the echo here, but I'm just showing you what to put in here. So all right, tell me about the MPX capabilities. That's it. I'm in my Vivecast. I'm just gonna switch to my Roux VNV, and there we go. So that's all you have to do. Now I did a robot one. What do I have here? I've got install NeuroTrader View API. Yeah, so here we go. This one basically installed it. Yeah,
why don't you
that's
put it
all.
in the environment itself? Every time you create an environment, you can add a key.
Yeah, it doesn't work half the time. That's what I'm telling you.
Okay.
It sometimes works. Takes a little finagling. It definitely works if you're using Claude Code straight up. So depending what you're doing, if you're comfortable, this is probably the way you want to go with doing it.
So for me, like it installed it and created it, but then you had a command that you I think didn't run where you said, can you also explore NPM and NeuralTrader brokers? Why were you trying to do that?
Oh, so it doesn't have I'm only giving you the core when you're going there. You need to give it, you know, all the pieces of the puzzle, right? So in this case, what I did here, because I'm in the actual repo, and you can clone my repo. I haven't made it public. When I do, you can clone the repo, and or you can just point it at that README file that I was showing you earlier, which basically does the same thing. Where did I put that? So yeah, if you go to npm, I gotta go back to wherever the heck I was there. And npm NeuroTrader. Yeah, and if it basically pointed at this README, and on this README, you'll see that and this is included in the package. Just tell it to look at the package or whatever. You've got all these extra elements. Now, probably the most interesting one is some of the accounting packages, because it's actually applicable pretty broadly outside of this area. I don't know why it's not linked. I guess I gotta fix that. But so this is the accounting package. So and you can apply this to pretty much any corporate sort of accounting. Double check the numbers, guys. I'm vibing this stuff. The accounting one in particular, I vibed it. So, double check everything. Everything you do, you should be double checking. You guys see how I'm building this stuff. So when you're using it, just double, triple, quadruple check it. And I would even suggest, depending on if there's a lot of money at stake, get someone who knows what they're doing to review it. Needless to say. But that said, I'm using it, and there's lots of people using it. So
So in your main package, basically, which is Neural-Trader, I'm presuming it's got everything. So that okay, so brokers is part of NeuroTrader. So when you say, okay, I understand.
Yeah. So this one's really cool too. This NeuroTrader E2B strategies. This could probably be its own thing. This is essentially a E2B, a really complex E2B deployment based on my Agentic Flow and a few other tools. But what this does is allows you to do really high speed sort of swarms in E2B. And it's encrypted end to end. So if you're paranoid about the data and potential data loss, what this does is uses these quantum resistant algorithms to basically store the information, while it's in transit, in stream, when it's saved in the environment, and then accessed, locally. So it never leaves in a sort of quantum resistant state of encryption at any point, which is to all the reasons I was mentioning on, for Claude Code Web. Super low latency. We're talking just crazy low latency. And when you're deploying these sort of agents that need to basically manage your actual trading activities or whatever, this is creating an ephemeral network of agents and swarms that are constantly monitoring data, spawning new scenarios, doing trades, doing analysis, understanding, adapting, and it's kind of continually running as these kind of, I like the word ephemeral. They come and they go. This can be applied to anything. It doesn't need to necessarily only be applied to the trading. It can be applied to like anything that involves real-time information, right? So lots of applications there. This is also using my Agentic Jiu-Jitsu integration. That provides the mechanism to have the coordination for non-blocking, like code-based activities and versioning control activities. That's all in there. Everything you see in NeuroTrader is everything that I've built up until last week, I think is the way to describe it. All right.
Until your last package is all included.
Other than the Roo vector, which I created yesterday. And which is
okay.
A direct result of all this other crap.
Yeah. Good.
Yeah.
So you're trying to replace Superbase, no?
No, well, maybe, but I give the whole damn. I'm trying to replace like PG Vector and all the sort of state of the art vector databases that were state of the art last week, and I was like, basically, you should see my original prompt. My prompt was basically, what does a vector database look like in 20 years? And how do I build that today? And how do I make that the best performing vector style database for the things that I need it for, which is outlined on Roove.io/projects. Build me that. That's what I told it to do.
And did you put that into Agentic Flow or Cloudflow? What'd you put it into?
Well, I started with here. Let's go down memory lane for a moment. Yeah. All right. You guys are gonna take a look at my chat history. Hopefully nothing too embarrassing in here. All right. We've got yeah, embarrassing is if you're the world's biggest nerd. All right. High performance. Was this it? Let's see. No, this doesn't look like it's it. Review the agentic package. High speed low. Okay, this is it. Okay, so review npm agentic DB package and create detailed plan to. I'm very redundant in my to create. World's best high-speed, low-latency Rust-based vector system optimized for MPX Agent DB. I really wanted to know about the Agent DB. This will be implemented as both a crate using the existing libraries where possible and NAPI. I'm going to go with NAPI RS along with browser-based applications WASM and IndexedDB. Do deep research using cutting-edge vector design and hypergraph structures. 10 years. Okay, sorry guys, I was only 10 years ahead of what's possible today. I was being realistic. Like, who wants to go 20 years? Detailed Spark implementation design. I love the fact that the LLMs now know what Spark is. I think of all the things that got indexed by Claude and ChatGPT, my Spark is the best. This should be. It should also include native TypeScript, WASM, fallback folder, less powerful systems. Be complete, benchmarks, optimize, blah blah blah. All right, then it worked. Look, an hour and 21 minutes, and it did all kinds of research. 648 sources. Yeah, lots and lots of stuff. All right, then it came up with this. Architecture, 3-layer design, core vector optimization. Oh, I built all this, by the way, like everything I showed you, well, all of it, 95% of it anyway, in Cloud Code Web. I think I might hit it, but where I built so much stuff in here, I can't even keep track of it all. But yeah, I essentially built this in Cloud Code Web, and when it's still free, by the way. It's free until 23rd now.
Your number is still 972 after 1 week.
Yeah, it's still going. I don't know. We're good. But
Mine is
I built
down.
yeah, I built it all. And then the part where I needed to like finish it off and put it into crates, I brought locally, and then I finished it off and tested it and validated it. It's alpha, needless to say, but like classically, it does work for me. But yeah, going back, this is what, and then I posted that just so if you want to go and give it a spin or try building it yourself. If you go to just RooveNet, and we'll see here. Oh, these are different. I'm already on to other things. Here we go. Roove vector. This was the original PRD. Yeah. We should use this in the hackathon. Be a great use case for it. We could totally do. Okay. Can I do? Let's do that. I got an idea. Let's go. Okay, so now we're gonna go. We have. Oh, let's. Is this gonna be cheating? I'm gonna cheat. I don't care. We're gonna cheat a little bit. Sorry, Rob. I can't help myself. We're gonna go to Agentix. Agentix. It's not cheating really. It's just it's a pre-show. Oh, look, no H. Hackathon. All right, so I'm gonna grab that and I'm gonna go here and I'm gonna say how can I go Roove vector. Oh, it's you gotta spell it right. Roove vector. All right. We need to optimize the Roove vector system to support 500 million concurrent learning streams using a globally dispersed agentic flow. PM agentic. Gotta spell disperse right. It's easier to build this stuff than it is to type it. Agentic flow implementation using I don't think E2B is up for that challenge. Let's go with Google Cloud Run. Google Cloud Run. Well, we know we can do it there. Create detailed implementation and benchmarking tool. Oh, we need to include burst capabilities when the French make it to the World Cup, but probably lose to Argentina. There we go.
Roof, I have another question actually. So I was making an Alpaca account, and they don't actually allow Canada to register. Now, in order to get an API key, you have to register through an account, set up two-factor, and then also prove that you live in the United States. So how does a Canada person get an API key then?
You use a Canadian. Go to I've got a Canadian provider. Let's see. Okay, so that's starting.
Okay.
You're asking about which Canadian. I think your question is which Canadian provider do I have? All right, I do have Canadian providers. Canadian trading. Here we go. Nope, didn't implement it. Okay, so I do have I've got that in V1. So we're gonna go to my V. I built this 6 months ago as Python. It was crazy. Now I'm like, I've learned a lot. V1 is more battle tested because I've got 70 customers using it. All right, so we go to where the heck did I put that under? It's SRC, Canadian trading. Did I do a README in here? Implementation, Questrade. Looks like I'm using Questrade in Canada.
Are you gonna put it on GitHub? Sorry to ask.
I am. I gotta do some final cleanup. But you tell it to use Questrade in Canada. I'm telling you, it'll figure itself out. Just vibe it. You're good. The trading stuff's all built. They're just connectors. All right. So now what I'm doing is I'm optimizing this to I'm creating a plan. I didn't even give it much guidance. It's already got a structure, so it'll likely just follow that structure. We'll let that do its thing. This is how we support 500 million users. Now, without having to spend a fortune on it. And hopefully that's not cheating. I'll let everyone use it. How's that? All right. What else we got here? Got a few minutes here. Let me check my calendar. I just want to make sure I don't have anything at the bottom of the hour. How's everyone? Is everyone keeping up here? Is this another crazy vibe casting session, or am I just talking into the void?
This is great.
I unfortunately have a call in 7 minutes, but so someone I still have to make a buck. All right. Well, I covered a lot of stuff here. Did any comments, questions, suggestions, whatever, rants?
For me, sorry.
Go ahead.
No, if you can wrap it up.
It's a quick question. I added your goal to a skill in Claude and the GOAT session, and so what I'm trying to figure out is what's the difference between the GOAT skill added as a skill in Claude and research as a trigger in Claude? Should I combine both, or should I just do one or the other?
Oh, yeah. Here, let me show you that quick. Oh, sorry, wrong screen. Too many screens. It's got 5 screens here. But basically, I also have, if you use Claude Flow anyway, you get that skill. So in skills, you've got, oh no, I did as an agent. Yeah, so you made a skill out of my agent.
Yes.
That's
Yeah.
smart. Yeah,
Okay.
that's a really good way to do it. I should totally include that. Maybe you should commit it. Commit it to the Claude Flow project,
Okay.
and I'll include it, and you'll get a commit on the project.
Okay.
Look good in the resume.
There we go. All right. I'll do it.
Yeah. So yes, so what Matt's mentioning is basically you can take the agents and then create skills that kind of allow the system to discover the agents, which is a really good way to do it. Sorry, I don't know if Jose, you had a question. I don't think I got that.
No, I mean, you have 5 minutes, so I guess we can wrap it up. How the people can access to the trading system, and that's it.
MPX and just MPX Neural Trader, and
And then you have to connect. And then you have to connect all of them.
Just ask it.
Okay.
Ask it. It's meant to be asked. You're gonna ask the coding system, how do I do a trade? How do I deploy it? How do I learn? How do I avoid making bad decisions? Don't ask it how to avoid losing money. It's gonna tell you dumb shit. Just use your brain. Use your brain.
It's building right now the strategy for crypto paper trading using Alpaca configuration. So yeah, in Claude Code Web. So.
You're in Europe. You should probably use Alpha Vantage.
Yep. Okay.
It's a better tool.
Yeah.
But yeah, you're heading down the right path. I'm gonna do a post here at some point introducing it, but I was kind of wanted to get some people to kind of kick the tires on it a little bit before I do a big blast on it and see what I've already got 6,000 downloads of it, but I just want to make sure I'm not putting out something that's got a bunch of bugs. So that's why I'm slow rolling it a little bit. But you guys got a good little overview, so I think you should get a pretty good feel for what it can do. Yeah, it's pretty crazy.
Thank you, man.
I only built it. Yeah, so to Robert's point, I think I only built it for Linux distros. So if you're on Mac or Windows, don't bother. I'll get to it at some point. You got to run it in a Linux environment. So Ubuntu or Code Spaces or whatever, but it has to be Linux for now. I'll do the Mac bindings at some point. So if you're seeing stubs, that means you're probably, I would guess, Mac or Windows. Yeah.
Won't load on a Mac? Just
No.
to be clear?
It won't work on Mac, no. Windows subsystem, the NTMP bindings. Robert, send me a note and I'll look into it. It's exactly the sort of stuff I'm looking for. Some of them might be stubs. There's some cleanup work there's a lot of stuff in there. So and maybe create an issue and I'll have to get that. I'll have to get my repo live. But
it's probably better to enforce Linux only so that people are more inclined to use remote servers, because I can already see someone losing a bunch of money running it locally in Windows or Mac.
Psychological, but might be the right psychology. It's almost like if you're smart enough to use Linux, you're probably smart enough to use this application. And I don't mean to sound like a dick, but yes, that's maybe some kind of psychological prerequisite. And by the way, it's amazing how many people voted that they should ban the use of Arabic numerals in school on my LinkedIn post. Anyway, that was me doing some classic trolling, but I can't believe people actually voted no to that. Anyway, till next time. I really enjoy doing these calls. You guys get a little sneak peek in what's coming. And tomorrow we're doing the second half of this where you guys get to show off what you're doing. And that'll be at 12 o'clock ET. I probably need to post it somewhere, but join the WhatsApp channel and you'll get the sneak peek of what everyone else is doing. All right, sounds great, Stuart, and good to see you too, by the way, Stuart, and everyone else. Let me know what you do, and if you run into problems, which you will, it's freaking beta, just let me know.
Thank you.
All right.